El Niño is a natural phenomenon that occurs when the surface waters of the central and eastern tropical Pacific Ocean become abnormally warm. This warming affects the atmospheric circulation and shifts the patterns of rainfall and cloudiness across the Pacific and beyond. El Niño events usually last for several months and have a significant impact on the weather and climate around the world. One of the regions that is most affected by El Niño is Australia, especially the eastern part of the continent. El Niño typically brings drier and warmer conditions to eastern Australia during the winter and spring months, reducing rainfall and increasing the risk of drought, bushfires, frost and heat waves. El Niño can also delay the onset of the monsoon season in northern Australia and reduce the number of tropical cyclones that form in the Australian region. The reason why El Niño affects the weather patterns in the Pacific Ocean and Australia is because it changes the distribution of heat and moisture in the atmosphere. Normally, the trade winds blow from east to west across the tropical Pacific, pushing warm water towards Indonesia and Australia. This creates a pool of warm water in the western Pacific that fuels convection and rainfall. At the same time, cold water upwells along the coast of South America, keeping the eastern Pacific relatively cool and dry. However, during an El Niño event, the trade winds weaken or even reverse direction, allowing warm water to spread eastward across the Pacific. This reduces the temperature contrast between the East and West Pacific and shifts the zone of convection and rainfall towards the central and eastern Pacific. As a result, Indonesia and Australia experience less rainfall and more dry spells, while parts of South America receive more rainfall and flooding. The strength and duration of El Niño events vary from year to year, depending on how much the sea surface temperatures deviate from average and how well they couple with the atmospheric circulation. El Niño events are typically defined when sea surface temperatures in a region called Niño 3.4 are more than 0.8 degrees Celsius above average and when a measure of atmospheric pressure called the Southern Oscillation Index (ENSO) falls below -8. El Niño events can be classified as weak, moderate or strong based on these criteria. Some El Niño events can also be classified as extreme when sea surface temperatures exceed 1.5 degrees Celsius above average in the central and eastern Pacific. El Niño events are part of a natural cycle called the El Niño-Southern Oscillation (ENSO), which also includes La Niña events, when sea surface temperatures in the central and eastern Pacific are cooler than average. The ENSO cycle operates over timescales from 1 to 8 years and has a major influence on global climate variability. Scientists monitor ENSO using various indicators such as sea surface temperatures, atmospheric pressure, wind anomalies, cloudiness and rainfall. They also use climate models to predict ENSO events based on current observations and historical data. One of the factors that can affect Australia's summer weather is the El Niño phenomenon, which is a periodic warming of the eastern and central tropical Pacific Ocean. El Niño can bring drier and hotter conditions to parts of Australia, especially in the southeast and inland regions. But what are the chances of El Niño developing in 2023 and how strong could it be according to the U.S. Climate Prediction Center? According to the latest ENSO diagnostic discussion issued by the Climate Prediction Center on April 13, 2023, ENSO-neutral conditions are expected to continue through the Northern Hemisphere spring, followed by a 62% chance of El Niño developing during May-July 2023, and a greater than 80% chance of El Niño by the fall. The report also states that the range of possibilities toward the end of the year includes a strong El Niño, 4 in 10 chance of Niño 3.4 greater than or equal to 1.5 degrees Celsius, to no El Niño, 1 in 10 chance. The Niño 3.4 index is a measure of sea surface temperature anomalies in a specific region of the equatorial Pacific Ocean that is used to monitor ENSO conditions. The forecast is based on several indicators, such as sea surface temperatures, subsurface temperatures, atmospheric winds, and convection patterns. The report notes that while the warming near coastal South America was striking, the basin-wide coupled ocean atmosphere system was consistent with ENSO neutral. However, The recent oceanic Kelvin wave plus recurring westerly wind anomalies are anticipated to further warm the tropical Pacific Ocean. The coastal warming in the eastern Pacific may foreshadow changes across the Pacific Basin. The Climate Prediction Center also provides a probabilistic strength forecast for El Niño, which shows the likelihood of different categories of El Niño intensity based on historical data and model predictions. As of April 2023, the forecast shows that there is a 0% chance of a weak El Niño, Niño, 3.4 between 0.5 degrees Celsius and 0.9 degrees Celsius, a 28% chance of a moderate El Niño, Niño, 3.4 between 1 degree Celsius and 1.4 degrees Celsius, a 40% chance of a strong El Niño, Niño, 3.4 between 1.5 degrees Celsius and 1.9 degrees Celsius, and a 32% chance of a very strong El Niño, Niño, 3.4 above 2.0 degrees Celsius. The forecast is updated monthly and is subject to change depending on how the ocean atmosphere system evolves over time. The next ENSO diagnostics discussion is scheduled for May 11, 2023. To receive an email notification when the monthly ENSO diagnostic discussions are released, please send an email message to SEP. List. ENSO update at NOAA. El Niño is a climate phenomenon that occurs when the sea surface temperatures in the central and eastern tropical Pacific Ocean become warmer than average, affecting the atmospheric circulation and rainfall patterns around the world. In Australia, El Niño usually brings dry and hot conditions, especially in the eastern and southern parts of the country. Some of the potential impacts of El Niño on Australia's summer weather are drought. El Niño reduces the amount of rainfall in eastern and southern Australia, increasing the risk of drought. According to the Bureau of Meteorology, 9 of the 10 driest winter to spring periods for eastern Australia on record have been during El Niño years. Drought can have severe consequences for agriculture, water supply, ecosystems, and human health. Heat waves. El Niño years tend to see warmer than average temperatures across most of southern Australia, particularly during the second half of the year. In general, decreased cloud cover results in warmer than average daytime temperatures, particularly in the spring and summer months. Heat waves can cause heat stress, dehydration, heatstroke, and even death for humans and animals, as well as increase the demand for electricity and water. Bushfires. El Niño increases the fire danger in southeast Australia by creating dry and hot conditions that make vegetation more flammable. Combined with strong winds and lightning strikes, El Niño can trigger devastating bushfires that destroy homes, properties, wildlife, and habitats. For example, the 2019-20 bushfire season, which coincided with a strong El Niño, was one of the worst on record, burning more than 18 million hectares of land and killing at least 34 people and over 1 billion animals. Coral bleaching. El Niño raises the sea surface temperatures in the tropical Pacific Ocean, which can stress coral reefs and cause them to expel the algae that give them their color and nutrients. This is known as coral bleaching, and it can lead to coral death if the stress persists for too long. Coral bleaching can affect the biodiversity and health of marine ecosystems, as well as the tourism and fishing industries that depend on them. The Great Barrier Reef, which is the world's largest coral reef system and a UNESCO World Heritage Site, has experienced several mass bleaching events due to El Niño, most recently in 2016-17.